Good afternoon, Math 3. Well, it's probably good morning if you're watching this. It's afternoon for me when I'm making this, but regardless, welcome to today's lesson on solving two-step equations. In your book, this is Chapter 3, Section 5. Make sure you have your name, date, and chapter and section titles in your skeleton notes as you're following along with me on this video as we go over this section. Okay. For this section, what I want you to be able to do is to be able to describe to me how we solve these two-step equations. We've been working on just one-step equations. We either had to subtract or add to one side of our equation to find our answer, or a last section multiply or divide to each side of our equation to find our answer. This section, we need at least two steps to find our answer. So, the I can statement you're going to write, okay, give me a second here, I'm trying to plug in my smartboard. Be right back. Okay, I think my smartboard is plugged in now, sorry about that. The I can statement that you want to write, your learning target is, I can describe how to solve two-step equations. Okay, write that maybe towards the top right-hand side of your skeleton notes. By the end of this section, that's what you want to be able to do. Describe to me how to solve these equations. If you can describe them, then at least you know the steps, and then the math will come, as long as you continue to practice. Okay, it is very similar to what we've been doing. All you need to keep in mind, and some of the first questions that help you solve these problems, is when you ask yourself, what undoes the operation? Except now we're going to have two things. Okay, so in your skeleton notes, you'll see it says keep the thought process of what undoes the operation. Okay, if you need to pause this video at any time, go ahead and do that so you can fill in your notes as you go. The steps to follow come next, and they are listed here for you in blue. The first thing that you need to do is, just like you did last section and the section before, split it at the equal sign so that you know you have a left-hand side and a right-hand side of your equation. It's just like balancing a scale. Number 2, this is a new step. It says get rid of the constant. Well, we have to remember what our constant is. Our constant in our equation is the number. Okay, so it could be something like 5. It could be something like -2. Okay, don't get constant confused with a variable or a coefficient. For example, 3x. This is not a constant. A constant is just a number. You want to get rid of your constant first. Okay. Then, lastly, you isolate the variable, which means you get the variable all alone. This is very similar to what you did in the last two sections. So we're just adding in a step from 3.4 and 3.3. And that step is number 2, getting rid of the constant. Okay, and I'll show you why we need to do that coming up. After you have your steps down, it's time for our very first example. And I think you'll start to see a pattern and start to catch on. Example 1, please write this in your skeleton notes, says solve -3x plus 5 equals 2, and check your solution. Okay, first step would be to write it. -3x plus 5 equals 2. Some of you remember Our first step is to split it in at the equal sign. That's good. So now we can see the two halves of our equation. That's the first step. Second step, if you don't remember, go back to your list. Number 2, get rid of the constant. What is our constant in this problem? What is just the number that's on the same side as your variable? Remember, we're trying to get x all alone. So the constant we should focus on is the number, just the number that's on the same side as our variable, which in this case is x. Hopefully you've identified that our constant that's on the same side as the variable is 5. It says plus 5, so undoing that, getting rid of the constant, would be subtracting 5 on each side of our equation. Well, once I do that, I can see 5 plus 5 minus 5 is 0. That cancels out. Perfect. That's what I wanted to do. I wanted to get rid of my constant. And I'm left with 2 minus 5 gives me negative 3. On my left-hand side, I did nothing with my negative 3x, and I'll bring down my equal sign as well. That was the first step. The first step is in red, getting rid of my variable. The second step I will do in purple. Okay, after I get rid of the constant, excuse me, I think I said variable. The first step, remember, is to get rid of your constant. Get rid of your constant. Okay, now number 3, I can isolate my variable. I can get my variable all alone. Well, how do I do that? Good question to ask yourself. How can I get my x alone and what's being done to it? Well, remember that a number smushed next to a letter, it means that it's multiplying. So in this case, I'm multiplying by negative 3. How do I undo that? I have to divide by negative 3. Both sides of my equation. What happens when I do that? Well, negative 3 divided by negative 3 is going to cancel out because it gives me x. It gives me 1x, which is what I'm looking for, equals negative 3 divided by negative 3 is 1. And box my answer. Okay, it said to check your solution. Let's do that. Check our solution up here. So in my equation, wherever I see an x, I'm going to now substitute the value 1. Okay, I had negative 3 times, well I found out x is 1, I'm going to plug that into my equation, plus 5, this has to equal 2. Well, let's check and see. Negative 3 times 1 gives me negative 3, and negative 3 plus 5, does that equal 2? Yeah, it does. Negative 3 plus 5. It's like if you have 3 negative counters and you had 5 positives. Remember, your positives and negatives will cancel. And what are we left with? We're left with 2 positives. So yes, it does check out. 2 does equal 2. Our solution is correct. Whew. Seems like a lot of work. Seems complicated. It's 2 steps, guys. It's 2 steps. Just tell yourself, get rid of your constant first, and then isolate your variable. I'll do the first on your own problem here, and then put the answers for number 2 and 3. So at this time, it'd be a great time to pause your video, try each one of these on your own, and see if you come up with the correct answer. Alright, I'm going to split this equation at the equal sign. I'm going to get rid of my constant. In this case, it's 12. I'm going to subtract 12 from each side. Undo this, because 12 minus 12 is 0. I'm left with 2x equals, and 4 minus 12 should give me negative 8. And then I have one last step to isolate the variable. What's being done to 2? It's being multiplied by 2. So the opposite would be to divide by 2 on each side. And I'm left with x equals negative 8 divided by 2, they have different signs, so my answer is going to be negative, and 8 divided by 2 is 4. If I plug that back into my original equation, it should check out. The answer is negative 4. Next one, I have negative 5c plus 9 equals negative 16. Okay, I'm going to subtract 9 from both sides. I'll go a little quicker here. Be left with negative 5c equals, if you need to write it horizontal, do that. Negative 16 minus 9. I think you can see you're going to need a chop here. Okay, negative 16 plus negative 9 gives me negative 25. And last step, I need to divide by negative 5. I need to undo multiplying by negative 5. I'm left with c equals positive 5. And lastly, example number 3, we need to use the distributive property. Remember, to distribute means to multiply your outside number by everything that's on the inside. So 3 times x is 3x, and 3 times negative 4 is negative 12. Has to equal 9. Okay, now I can split it at the equal sign. I can get rid of my constant first. My constant is negative 12, so the opposite would be to add 12 on both sides. These would cancel. I'd be left with 3x equals 21. And to isolate my variable, right now x is being multiplied by 3, so the opposite would be to divide by 3 on both sides of my equation. I get 7. Hopefully you do too. If not, that's okay. Please ask and get a little more help. We'll spice life up a little bit more with example 2. It says solve x divided by 8 minus 1/2 equals negative 7/2. Follow your procedure. First step, split at the equal sign. Second step, get rid of my constant. What is just the number that's on the same side as my variable? Okay, my variable is x. What's the just number? What's the constant? Well, hopefully you see that it's 1/2. And what's being done? Well, it's being subtracted by 1/2, so the opposite would be to add 1/2 on both sides of my equation. Negative 1/2 plus 1/2 undo each other. They cancel out to get 0. And I'm left with x divided by 8 equals negative 7/2 plus 1/2. Negative 7/2 plus 1/2. I have a common denominator already. I'll keep it. And negative 7 plus 1 gives me negative 6. And negative 6 divided by 2 gives me negative 3. All that worked out really nice. Last step, ask yourself, what is being done to x? In this case, it's being divided by 8. So to undo that, I would multiply it by 8 on both sides of my equation. Remember, 8 times x over 8 is like saying 8 over 1. These would cross simplify, and the only thing that you're left with is x. Perfect. That's the only thing that we want remaining on the left-hand side. So x equals, and I have different signs. When I'm multiplying integers with different signs, I always get a negative answer, and 8 times 3 is 24. Okay, so negative 24. Plug your answer back into this equation and see if they balance each other out, if you get the same thing on each side. Okay, we're going to move on then to the on your own problems 4, 5, and 6. Again, this would be a great time to pause the video and come back and check your answers after you've done them to see if you're doing them right. This is also going to be a place for me to pause so I can start a new video for this last half. See you later. Alright, I'm back, guys. The program I'm using only lets me use 15-minute sections at once, so that's why I had to pause. But anyways, back to this math here. One thing that can be helpful for me is I find my variable is m, and I just think about the two things I need to do to get it all alone. I see that I'm adding 6, and I see that I'm dividing by 2. So the two things I need to do in this problem are just the opposites of that. Subtract 6 and multiply by 2. In this order. Okay, we're getting rid of our constant first. Let's try that. Somebody's in the room here. Let me pause for a second, I'll get back to you. Okay guys, sorry about that, I'm back. Brett was here collecting his money for the Big Buck contest. We need more people in it next year, just so you know. But some money did carry over, so the jackpot's going to be bigger next year for anybody who wants to get in the Big Buck contest. Anyways, back to math. Just got done talking about the two things that I need to do to undo whatever operation is being done to m. So I see that there's adding 6 and dividing by 2. So the opposites would be multiplying by 6, or excuse me, subtracting 6 and multiplying by 2. Okay, let's clear this just we can see a little bit better as we go through the problem. Split it, get rid of the constant, so subtract 6, cancels out. I'm left with m divided by 2 equals 4. Then all you have to do is multiply by 2 on both sides, and you found your answer. M equals 8. Okay, double check that by plugging in 8 into your original equation for m. I won't do 5 and 6. If you have questions, let me know. But for 5, you should get z equals negative 12. And for number 6, you should get a equals negative 2/5. Negative 2/5. Alright. Moving on then to example 3. We have a situation where on the left-hand side of our equation, hopefully you can see it, we have like terms. Okay, if I were to split it at the equal sign, on the left-hand side I've got 3y minus 8y. Well, I can do that. I can take 3 pizzas and subtract 8 pizzas from there. That is negative 5y equals 25. And then you can just solve it like a simple equation. What's being done to my variable? It's being multiplied by negative 5. So the opposite would be to divide by negative 5 on both sides. Y equals, different signs when I'm multiplying or dividing integers, equals a negative. And you should get 5. Y equals negative 5. And lastly, we have a real life example. Example 4. Talking about roller coasters here. It says the height at the top of a roller coaster hill is 10 times the height h of the starting point. The height decreases 100 feet from the top to the bottom of the hill. The height at the bottom of the hill is negative 10 feet. Find h. Okay, so if you couldn't quite tell yet from this problem, it's probably going to be helpful for you to write an equation that will help us solve this problem. Okay, writing this equation, I can kind of go in order, as the same order as you read. Looking at our starting point, we start at our height labeled h, and it tells us that the height at the top is 10 times of our starting point. Okay, so 10 times our starting point, 10 times h, well, that's just represented by 10h. That's our distance at the top. Okay. We also know it tells us in the next sentence that the height decreases 100 feet from the top to the bottom. Well, how could you write decreases in math? Definitely by subtracting 100. A decrease is 100 feet from the top to the bottom. The last sentence tells us the height at the bottom of the hill is, big hint, is in math often means equals -10. There's our equation that we need to solve to find h. And h represents the height at which you start. You guys know that. Oftentimes when you get on a roller coaster, you have to go up some steps to get to the start of it. Okay, looks like this is the case as well. I need to solve for h, so split my equation in two. Two things I need to do. I can see that it's being subtracted by 100, and it's also being multiplied by 10. So I just need to do the opposites of those. Add 100, getting rid of the constant first, and then dividing by 10. Excuse me. Okay, first I'll add 100 to both sides, undoing the constant. -100 plus 100 cancels out, that's 0. I'm left with 10h equals, and -10 plus 100, same as 100 minus 10, 90. Last step, to isolate h, to get h all alone, I need to divide by 10 on both sides. That cancels out, gives me a height of 90 divided by 10 is 9, and my label is feet. Alright, that wraps up 3.5. A little bit more complicated than the last two sections, but the same ideas. Just remember, pretty much the only new thing we added is that first you need to get rid of your constant. Okay? If you do need more help on this, it's a great resource right here. Please check out this Khan Academy. Now or in your spare time is just fine. He explains it in maybe a little bit different way that could help you. So check that out. I'll also post it to Google Classroom if you need. Hopefully your skeleton notes are now complete, and Gillis is out.